Hey class, so for today's first remote learning assignment, what I'm going to do here is I'm going to give you some notes on something called Ohm's Law. You can go ahead and watch this video a couple times if you need to. I'd like you to go ahead and take notes on the things that I'm going to give here, except for when I get to the last few example problems at the end. This is actually going to be pretty easy and pretty straightforward, but it's actually pretty important for doing the rest of the things that we're going to do with circuits. Ohm's law is just pretty much a formula between three things that happen within circuits, and we've already mentioned these terms before, but now we're going to get a little deeper into what all these things mean. So the first thing that you should know is that every circuit has something called voltage. Voltage is pretty much just electrical pressure, also sometimes called electric potential. It pretty much just means that the energy has the potential or the ability to give electrical energy to a circuit, and it's kind of the energy that is supplied by a battery or a generator or something in a circuit. The symbol for this is V. So you might say the voltage V has a certain amount of, and then the unit would be volts, which we could also abbreviate with a V. So in a circuit, you might say in your house has an electrical outlet that has a voltage of 120 V or volts. The next thing that we also mentioned the other day is resistance. And resistance is the opposition to electricity. We talked about this before. We had you guys measure your resistance. We had you measure resistances of the resistors that we put into our circuit boards. Everything has some sort of pushback against a battery, against the voltage. That's something that's trying to create electricity. And that could range, which we'll talk about here in a second. The symbol for this is going to be R, and the units is going to be ohms, which is a guy's last name. But instead of writing O for ohms or just writing out the whole word ohms, we use a horseshoe symbol that looks kind of like that, which is a Greek symbol, omega. The last thing, and this is the thing you guys know, which is current. Current is basically what you guys know as the amount or the rate of electricity. The symbol for this is not C, it's going to be a capital I. And the units for this are going to be amps or A. So all three of these things are in every circuit that we are always going to deal with. Now, just to give you some background information, voltage can range. Like you could have, you might have a voltage of maybe 1 volt in a circuit, or you could have a voltage equal to 100,000 volts, depending on the object that you're using. So a voltage can be a very large number or a very small number relatively. The same thing also goes with resistances. We could have a resistor in a circuit that might have 1 ohm of resistance. Meanwhile, you guys might have had resistances of 100,000 or 1,000,000 ohms. So those numbers can range. Current's the one that you might want to pay a little more attention to. Just the way it works out mathematically, you could have a current I equal to maybe 0.001 amps, or you could have a current maybe equal to 50 amps. 50 amps is a ton of electricity. It is a lot. So if you are starting to get currents in a problem that are 50 or more amps, you may want to look back and see if you did the calculations correctly. Moving on, voltage, current, resistance are kind of like this analogy I have here with this pump. Let's say you had a pump pushing water through some sort of a hose and it went through some sort of a kink right here, or maybe this is some sort of a filter right there. We could make an analogy that the voltage is the pump. The voltage in a battery is what supplies the energy to push electrons through the circuit. So in a way, the voltage is the pump that creates the pressure to push, in this case, water throughout this hose. Our current would be the water. It is what is flowing through our circuit. And just like I said, every circuit has some sort of resistance. This resistance might be this kink or this filter, whatever is slowing down that water from going through that hose. Moving on, the formula is very easy. The formula is just V equals I times R, which obviously mathematically means that I is equal to V over R, and R is equal to V divided by I. And that is basically right there. That is Ohm's law. Okay, and what this should tell you is two relationships. That's as the voltage goes up, the current I will also go up. If you have a circuit with a 9-volt battery and you increase that to 18 volts, the current should go up. Conversely, if you have a circuit with a certain amount of resistance, if you were to increase that resistance, the amount of current will actually decrease in that circuit. So those are two relationships that you guys should know. We're almost done here. So we can use that formula that I just showed you guys up there, and we can go ahead and solve for problems really, really easily. Okay. So I'm going to do 3 here, and then you don't even have to write these down. You can just watch me do these, and then you can go straight to the Google Doc, go right to your calculator. You don't even have to show me any work for these math problems, and you can just go ahead and submit it. So it says here in this first problem that a home outlet supplies 120 volts to a 60 ohm light bulb. How much current flows through the light bulb? So using Ohm's law, V equals I times R, we have 120 volts. We have a certain amount of current in a 60 ohm light bulb. Mathematically, we can divide both sides by 60, and we get a current I of 2 amps. I would say that the main issue right now is just making sure you put your units and getting your symbols and everything correct. Next problem, number 2, says a 9-volt battery allows 2 amps of current to flow through it. How much current is in the circuit? So Ohm's law, V equals I times R. 9 is equal to I think I meant to say actually how much resistance, sorry about that, how much resistance is in the circuit. So what we could do is we could say 9 equals 2 times R. And then we could solve and say the resistance is going to be 4.5 ohms. Sorry about that mistake. And the last question. What is the voltage supplied to a circuit that has a resistance of 100 ohms and a current of 3 amps? All right, so V equals I times R. Therefore, we have a resistance of 100 ohms, and we have a current of 3 amps. Therefore, we have a voltage supply of 300 volts. So that's all I want to do today. Go back and rewind if you missed anything, and go ahead and then use this to complete the Ohm's Law worksheet that I've put in Canvas, and let me know if you have any questions. Thank you.